Alright, we're on the second video for this section using rules of exponents, and all the rules that you've learned so far are going to be applied here, in different ways and depending on the problem. For instance, on this first one, we can see we have negative exponents. It's a quotient. We have x's and y's, and there's a lot of things going on here. Now, one way that you can work with this is to rewrite all your negative exponents as positive. So that's the way I'm going to go with this one, just, because I'm trying to show you different ways to get started. So let's start here. All right, so the 8 goes to the denominator with a positive 2 exponent. The x squared stays because it already has a positive exponent, but x to the negative 3 to the denominator, and then that's a positive 3. If you can tell, that's a 3. And then my y to the 11th stays because it's positive already, the exponent. And then y to the negative 5, I'm going to change to y to the 5th in the numerator so that I can rewrite that exponent as positive. Now this one actually works out pretty well this way. Then all you have to do is simplify from here, add the exponents on the y's, take 8 to the second power. So that's going to be, I can't write a straight line here at all. It's going to be a 64. Add the exponents on your x's, and so you end up with x to the 5th power. Now, one of the common mistakes is that students start getting mixed up on when do I add and when do I multiply. So remember, when it's just a product you're adding. If you're taking a power to a power, then you're multiplying. So that means there's a power on the outside of your parentheses, basically. Okay, so for this one, I'm going to apply, because I like to look at them and kind of think, what would be the best way to go here? Well, notice that all my exponents are negative, so when I multiply them by a negative 5 exponent, they all become positive, and that makes for a pretty quick problem. So on the x, I have negative 1 times negative 5, which gives me positive 5. On the y, it's negative 2 times negative 5. And then we have z to the negative 3 times negative 5. And we're finished with that problem. So that's pretty quick when that happens. We can't combine anything because my bases are x, y, and z, so they're not the same. Okay, so on this one we have to clear the first parenthesis because of the negative exponent on the outside, right? So this is going to be 5 to the negative 2, x to the negative 4, and y to the negative 8. And then that's going to be times, stuff is disappearing again. Okay, so I tried to take care of that problem. And then that's going to be times 3x to the 9th, y to the 4th. So I just went ahead and removed those parentheses. Now, from here, what should I do? Well, you know what I'm going to do? I'm going to first take care of my negative exponents. So in the denominator, I will have 5 squared, x to the 4th, and y to the 8th. And then in my numerator, I'm going to have 3 x to the 9th, y to the 4th. Okay, so then maybe I should have just added those. You know what, I'm going to do this a different way. So let's go back just a minute here. So I'm going to keep the 5 to the negative 2, and I'm going to add the exponents on the x's. So that's going to be and the y's. So that's going to be negative 4 times or negative 4 plus 9. What am I saying? And on the y's, it's going to be negative 8 plus 4, so that's y to the negative 4. And of course, I still have times 3. Okay, I think this will be better. So in my numerator, I have 3x to the 5th And in my denominator, I have 5 squared times y to the 4th. I think this is smoother this way. And that happens sometimes too. You start one way and you're like, that's not as good as I thought it would be. Let's do it a different way. So that's 25 y to the 4th, and then we have that simplified as much as possible. Okay, so here we go. Here's the next one. So we're going to apply the exponents on each one of these, and then simplify from there. All right, so here we go. We have 3 squared. I'm just going to go ahead and make that a 9. And z to the negative 4 over y squared. And then that's going to be times 9 to the negative 1, y to the positive 4, and z to the 3rd. Okay, so then I can maybe just simplify my negative exponents and make this one fraction. So what stays in the numerator would be the 9, the positive 9 with an exponent of 1, and y to the 4th. In my denominator, I'm going to take the 9 to the negative 1, so that's going to be 9 to the positive 1. And then also, I still have y squared. And then I'm going to bring down the z to the 4th and keep the z. I don't have to have a times sign. Z to the 4th. All right, I already had a z to the 3rd, right? Z to the negative 4 becomes positive in the denominator. And then I also rewrote the 9 to the negative 1 with a positive 1 exponent. So now we're here at this, 9 divided by 9 is simply 1. We can subtract exponents on the y's, right? I'm just going to take it over here. So y is going to be 4 minus 2, so that's y to the 2nd. In my denominator, right, my 9's equaled 1, so those are gone. I've taken care of the y. Add the exponents on the z's. And you can see that this one actually ends up being pretty simple in the end, and when it started, it looked like kind of a big mess. All right, so that's the end of the lesson. These take practice, and knowing which direction to go sometimes changes. Once you start, you're like, well, I don't like it. I don't like going this way. Let's start another way. And that often happens when you're working with exponent rules, just because you can use them in different ways depending on the question you're on. Okay, bye for now.